The objective of this activity is to verify the Pythagoras theorem using a graph. Let's understand the concept of Pythagoras theorem first. Whenever you have a right angle triangle, obviously a right angle triangle has one angle as 90 degree. So here I have marked angle B as 90 degree. A and C can be marked anywhere. Let's mark A here and C here. This side AC, which is opposite to the 90-degree angle, is known as the hypotenuse. So AC is the hypotenuse. The other two sides, they form the 90-degree angle, and that is the side AB and the side BC. They are also called the bases. And the third side, that is the side lying opposite to 90-degree angle, that is called the hypotenuse. A right angle triangle has a unique property. When you measure the three sides, like you measure AB, BC and AC, the square of the hypotenuse, that means whatever is the length of AC, if you square that length will always be equal to the square of the side AB added to the square of the side BC. So the sum of squares of the two bases, that means the two sides which form a right angle triangle, is always equal to the third side, which is the hypotenuse. So the square of hypotenuse is equal to the sum of squares of the other two sides. This is the unique property of a right angle triangle. To perform this activity, we require following material: a white chart paper, different sketch pens, geometry box, a pair of scissors for cutting work, Fevicol for pasting, and graph sheets. Let's perform this activity of Pythagoras theorem now. So to verify Pythagoras theorem, as you can see here, I have taken a cutout of a right angled triangle. The dimensions which I have taken are: this side, that is base, is 3 units, this perpendicular is 4 units, and the hypotenuse is 5 units. So you can choose the unit as centimeter or inches as per your convenience. Now if you paste it here on a white sheet of paper, and then you take a square, as you can see I have cut out a square of 3 units. 3 units is exactly the same as the base of this right triangle. If I place it here, you will know that the two sides, that is the side of this square and the side of the triangle forming the base, is actually the same. So this square has side 3 units, and therefore the area of this square is 3 into 3, 9 square units. And likewise you have to take another cutout here in which the side is 4 units. As you can see here, this square has side 4 units, and if you place it here, you will verify that the side of the square is equal to the perpendicular of the right angled triangle. So since this has side 4, the area of this square is going to be 4 times 4, which is 16 square units. All are marked here on that particular square. Likewise, the hypotenuse is 5, so you have to take a cutout, another cutout here, which has side 5 units, and so if you place it like this along the hypotenuse, it will exactly align itself with the hypotenuse like this. And now how does the Pythagoras theorem get verified? If you see this, if you name this triangle as, suppose I name it as A, B and C. So if you see the side BC, the square of BC is the area of this square, and that is 9 centimeter square. That is the, if I write it as BC square, you will get confused. I'll write it as area of square with side BC is 9 square centimeter. And likewise, the one with square, the one with the side AB is having an area of 16 centimeter square, and the one having the side AC has an area 25 centimeter square, and therefore the area of this is BC square. which is 9, and the area of this is AB square, that is 16. If you add 9 and 16, you will get the area of this square which has side AC, so AC square. And that is the exact statement of Pythagoras theorem. AB square plus BC square equal to AC square, and therefore 9 plus 16 gives you 25. And that verifies the Pythagoras theorem for this particular right angled triangle.